All right, you're probably starting to catch the pattern now for linear algebra. We start with Anki, then we go into grading my work from yesterday. So we got one problem with Anki first. What is the augmented matrix of a linear system? And it's the rectangular array of numbers that translates basically a linear system into a matrix. Rectangular array of numbers that represents a linear system. Good enough. So now we got the Anki done. What we'll do next is grade my work from yesterday. And then do another problem. And then recall what I did yesterday or learn from the proof videos. And then finish the rest of the day watching proof videos. So I'll be back after I grade and do my next problem. All right, got the question from yesterday correct. Just completed another question for today. So now let's recall what we learned about yesterday from the videos. So we completed the first video. Basically learned this analogy of like chess and doing mathematical proofs. Basically, each move in chess is analogous to a proof technique. And the art of chess and the art of doing proofs in math is knowing what technique or move to use and when to use it. Okay? Yeah, so the rest of these videos are going to be about different proof techniques. The first one we're learning is called the forward-backward technique, or the forward-backward method. It has two phases. It's the most important, first of all, it's the most important proof technique to learn because all other proof techniques can be understood in the basically through the lens of the forward-backward technique or in terms of the forward-backward method. Okay, so the forward method, we're creating more true statements based on the hypothesis. So I think that's basically everything from yesterday. We have not learned what the backward method entails yet. Okay. Cool. Forward-backward method. All of the techniques can be described in terms of the forward-backward method. Two processes, forward process, backward process. Okay, yeah, we got all this. Let's go ahead and get back into the videos. I'll be back to recall in a bit. I just got engrossed in the video. I wasn't paying attention at the time. Timer went off. So what have I learned? So typically we're going to start with the backward method. What do you do to solve or to do the backward process? Well, what is the backward process? That's something we learned. So like the forward process, you're creating new true statements from the hypothesis. Backward process is similar, but you're going to start with B and you're going to actually create a statement before B that makes B true. Okay, how do you do this? Well, first step is you ask a key question without symbols or notation. So an example we're using in this video is like, it has to do with like an isosceles triangle. It says like the area is this if the triangle is isosceles. So the first key question is, well, what is how do we define or how do we know we have a isosceles triangle? Well, we have two side lengths that are equal, basically. So the second step is to answer the key question like I just did. First without symbols, and then the second is to answer with symbols for the specific problem. The goal is to link both sides, so eventually get like a statement that's a version of A, and a version of B that are the same. Last forward statement and the first forward statement, or last forward statement and the first backward statement are equal, and that's where they link. I guess the prereq is last forward statement is the same. Okay, press the prereq for backwards methods to prereq is to define the conclusion. And hypothesis, but not as important. Basically, the key question is, how do I show that the conclusion is true, that B is true? Okay. Symbols get in the way of understanding. Just get in the way of like our understanding and muddy up the water. So keep it the key question without symbols or notation. All right, that's it for today. I'll talk to you guys later. See you.